Hey kids, welcome to Module 4. Hooray, 5th grade Eureka Math. And we jump right into looking at data. So just a couple things to know. We're going to be looking at line plots in Lesson 1. And what are line plots? Don't be afraid, it's just a tool to collect data. We're going to use a number line to do this. And so we'll be looking at mostly like a ruler, but the ruler doesn't have to be actually the size of a real ruler, although it can be, but you can make your own on the lines that they provide you. So the objective for this lesson is to measure and compare in Lesson 1 pencil lengths to the nearest half inch, quarter inch, and 1/8 of an inch, and then we're going to analyze the data through the line plot. Most important thing that you need to know is that each time you see an X, it represents one count or one person or one vote, unless there's a legend that says otherwise. So it's really important to know that that is pretty key there. What is the best way to jump in? I'll tell you. It's by doing the application problem. Very simple introduction to line plots in the application problem. So let's jump right in here and do this one very quickly before we do the lesson for Lesson 1. The following line plot shows the growth in inches of 10 bean plants during their second week after sprouting. Here's the title. Always look at the title. And then notice that if there are 10 plants, you better have 10 X's. 2, 4, 6, 8, 10. Yes, good job. It's nice when we do this beforehand, because when you create your own line plot, you need to know how to build up your X's. And if you haven't had any experience doing it, you might not know what to do. So, quick, easy questions. What is the measurement of the shortest plant? If this is our number line, the shortest plants will be closest to 0. So you look here, and this represents one plant. 2 of them represent the same amount, but it's not that there are 2 there, it's what number is this. So between 1 and 2, how many pieces are there? 1, 2, 3, 4, 5, 6, 7, 8. This is in eighths, so 1 would be 8/8, this would be 16/8, etc. So if it's broken into eighths, then this is going to be at 6. 1, 2, 3, 4, 5, 6. So this is at the 6/8 after 1. The measurement of the shortest plant is 1 6/8. You could also say 1, 2, 3, 4 and call that 1 3/4. If you wanted to mathematically do that, 1 6/8 is divisible by 2 halves, and that's how you can get 1 3/4 there. How many plants measure 2.5 inches? Find 2.5 on the number line and see that there are 2 plants, because 2 X's. What is the measurement of the tallest plant? Go down and find this tallest one. Again, we're using eighths. This is the 7th one. It's after the number 2. 2 7/8 inches is our measurement. Don't forget to label inches. And then what is the difference between the longest and the shortest measurements? Now they're actually asking you to do a little bit of subtraction here. Difference is the answer to a subtraction problem. So we're going to take our 2 7/8 and we're going to subtract our shortest plant, which is 1 6/8. And we have a very simple subtraction problem. 2 minus 1 is 1, 7 minus 6 is 1, and you should end up with 1 1/8 inches. So very quick, brief introduction to line plots. Now, this is the actual class assignment with Lesson 1. And don't worry if you're stuck at home and you don't have any data. I know with all the sicknesses rolling around, you might not be able to go into school and get a class set of data, but not to worry. I have a whole bunch of data here that we're going to use. So it says estimate the length of your pencil to the nearest inch. I have a pretty brand new pencil here. I would say this is about 7 inches. I'm just going to throw that out there. 7 inches. You can also put 7 inches instead of the little thingies. I just put those out of habit. Now, using a ruler, measure your pencil strip to the nearest, well, pencil strips are for if you're in class. We're not going to do those. We're actually going to measure pencils, but today you're just going to use all the data that I will provide to you. Measure your pencil to the nearest ½ inch and mark the measurement with an X above the ruler below. This ruler or number line is in ½ inch increments. The word increment is just a fancy way of saying this is what we're counting by, or these are the units of measure that are corresponding. Now on the top number line, it's ½ inch increments. But as you continue lower, it's ½ inch. And then at the very bottom, you'll see it's ½ inch. So it gets smaller and smaller, and we're going to see what happens with our data as we go further down the page. So using a ruler, we'll get our ruler and we'll actually measure our pencil. Now this pencil, I'm going to start at 0 for the eraser, and it goes a little bit past the 7. And hold on, I have to get it closer so I can see it with my eyeballs here, and you can see it too. If this is my ½ inch, I would say it's pretty close to 7.5. So I would put my X there. Now that's just going to be your mark, okay, for your own pencil. And if you have your own class data, your X would become part of your class data, okay? Now, since you're at home and you probably don't have a whole class set of data, we're going to use mine, and so we will be filling in all the rest of the data for everyone else's pencils, all the fictitious students' pencils. Now there will be one here at 7.5. Apparently I was the only one with a brand new pencil. And so we're going to fill in. I want you to do the same as I do. Someone had a 2.5-inch pencil. It was very small. It's one of those ones where they can barely write. One person had approximately a 3-inch pencil. One had a 4-inch. Two at 4.5, put 2 X's there. No one had a 5-inch pencil. But all of a sudden, we had a lot of pencils that had been ground down a little bit at 5.5. So above 5.5, I want you to put 8 X's. 1, 2, 3, 4, 5, 6, 7, 8. Squeeze them in. And above 6, we had 9 students who had 6-inch, roughly, pencils. 1, 2, 3, 4, 5, 6, 7, 8, 9. That's a lot of students. I usually have 32 in my class. Then 6.5, there were not a lot, only 2. But 7-inch pencils, I think I had just opened a new package of pencils. Okay, we've got 7 there. 1, 2, 3, 4, 5, 6, 7. Okay, so that should make up the whole class set of 32. I think somebody was absent, so including mine, it's a total of 32. So this is what a line plot does. It shows you when you have like a lot of data for one number. We'll get into mean, median, and mode later, but the mode is like what's happening all the time, which one comes up the most. Think of mode as most. M-O-D-E, M-O-S-T, sounds similar. We're not going to do any averages or the mean, and the median is usually the one in the middle, but we're also not going to talk about that today. We're just creating the line plot, okay? And the line plot is the number line with all the X's on it. So now it says, using a ruler, measure your pencil, strip pencil, to the nearest 1/4 inch and mark the measurement with an X above the ruler below. Construct a line plot of your classmates' pencil measurements. So again, we get out the measurement, the ruler. You start at 0 right at the tip of the eraser, and we want to have the tip of the pencil closest to the nearest 1/4 inch. So what happens is I have more marks to kind of refine my measurement. And remember, I said it didn't quite make it to the 7.5, but it's more past the 1/4, closer to the half than it is to the 1/4, okay? So if you look at these little tick marks, okay, you can kind of see, sorry, I'll move it so you can see it better. You can see that it goes past the 1/4, and then it goes 1, 2, it's between 2 and 3. It's almost 3 ticks past, so that means it's still closer to 7.5. So I'm going to put my X there at 7.5, and I'm going to add the rest of my data to my line plot so you can see how the data is distributed. So above this ruler, let's shuffle our numbers. They're not going to be in the exact same spot, so watch out. Don't just copy. Don't just copy what you have here. It's going to change a little bit. So if I have 2 and 1/4, we're going to put 1x here. And then we're going to put 1x on 3. And then you're going to put 2 x's on 4 and 1/4 and 1x on 4.5. Okay, now that takes care of those 5 smaller pencils. But then we kind of went back up to the bigger pencils. And this time on 5.5, I want you to put 3. 1, 2, 3. Notice last time we had a whole bunch. But now that we have 5 3/4, that is where a lot of our data is going to fall. Okay, so on this one, I want you to put 8. 1, 2, 3, 4, 5, 6, 7, 8. And then on 6, we had fewer because they got redistributed out here in the middle. So for 6, I want you to put 4. 1, 2, 3, 4. For 6 and 1/4, we have 5. 1, 2, 3, 4, 5. So again, getting redistributed down below and above. At 6 and 1/4, we have 5. Sorry, I just did that. And then at the halfway point, we have 1. At the 3/4, we also have 1. At 7, we have 4. 1, 2, 3, 4. There's nothing at 7 and 1/4, and my lonely tall pencil is the only one that is out here on the end. Okay? Moving right along, what you might have noticed is that we had a few big spikes at the top. As we offer more options, those big tall spikes kind of filter down and they fill in these more precise measurements. Okay? Now, we're going to take a look at this final ruler at the bottom, which has twice as many options for us, which means our data will change even more. Okay? These amounts, these increments are in eighths. So let's take our eighths. If you want to every now and then put in your halfway point, you can do that, but it's not necessary to number your number line until you're really getting into the nitty-gritty up here, and it will help you to add a few numbers. But at the very beginning, our eighths, or 4/8 if you will, we have one pencil that is going to be at 2 3/8. 1, 2, 3. So put 1x, be very careful not to make it too big, at the 3/8. Okay? Then we have 1x at the 7/8. That's the 2 7/8. Moving up, those were the 2 short ones, but we have some 3 pencils that are around 4. So what exactly are they? We actually have 1 at 1/8, 1 at 2/8, and 1 at 3/8. So that's how our data fell in class. This is our 3/8. Then we had a big gap getting up over 5. If you want to put in your 4/8 at the halfway, you might need your 5/8, 6/8, 7/8 so that you can have the appropriate number of x's above. Now for 4/8 or half, you should put 3 because that's how the data fell. For 5/8, guess what? We also had 3. Kids were very careful here. 6/8, 3, 1, 2, 3. 7/8, 4, 1, 2, 3, 4. For 6, you can put 2. For 6 and 1/8, put 1. For 6 and 2/8, put 2. For 6 and 3/8, put 1. For 6.5 or 6 and 4/8, put 2. And then there's nothing here, so skip 1. Put 1 at the 6/8. Then 3 at 7. 1 at 7 and 1/8. And finally, my pencil at 7.5, which actually, let's see, 1, 2, 3, 4. Yep, it's still at 7.5. That was the closest amount. Okay, so now we have our 32 X's representing all 32 people who voted or had a pencil this particular length. So notice what happens to the data. Again, very tall spikes on few numbers, moving down to lower tall spikes on, you have more numbers receiving data. And then as you break it down into a tinier amount, so we have eighths, it trickles the information down even further. So let's turn the page and see if we can make sense of this data, because the questions on the back are really asking you if you understand what's happening with this information. So use all three of your line plots to complete the following. First of all, compare the three line plots and write one sentence that describes how the plots are alike and one sentence that describes how they are different. Now, if you look back, you might notice that all the line plots have the same amount of x's, right? How many x's are there? Well, in my class, we had 32. So let's write one sentence about how they are alike. All line plots have 32 x's or votes. Okay, so they all have the same, but different is going to be how the data was redistributed. So each line plot has different amounts on the numbers. Don't end here, because there are more choices, or there were more choices on the second and third, oh, there go the lights, line plots. There we go. Look at me standing and waving my hand and writing at the same time. Woohoo! So, as your data is distributed, the numbers of x's per specific number, like say on the 6 or on the 7, they get redistributed into the 1/8, 2/8, 3/8, etc. Okay? Now, what is the difference? Ooh, that's the subtraction one. Between the measurements of the longest and shortest pencils on each of the three line plots. So what you might notice is that we've got, let's just do A, B, and C. The first one has 7.5, 2.5. Those are your longest and shortest. So take your 7.5 minus 2.5. That's a pretty easy problem, because it's we've got the 2 halves, and it's just a 7 minus 2 for 5, and then we've got our minus the 1/2. And so your difference, oh, yes, okay, no, sorry, the difference is 5, my goodness, because I have 7.5 and I have to put back the half. Woo, I almost forgot to do that. Equals 5. I almost forgot to do that. So the difference is 5. See what happens? You have to do the put back. There we go. Okay, so the first one has a difference of 5. Now let's see if that changes for B. Instead, we still have 7.5. Remember, my super tall pencil is going to keep us here at 7.5, but the lower number changed to 2 1/4. 7.5 minus 2 1/4. Now this time we have to have a common denominator, so make this 1/4. So 2/4. Okay. Now for this one, 7 minus 2, we've got the 5 again. But I can subtract in one step here because they have the common denominator, and I can do my subtraction. So I get 5 1/4 as the difference for line plot B. Okay, so 5, but different difference for line plot B. For C, we have 7.5, but 2 3/8 this time. Minus 2 3/8. And so instead of having fourths for my common denominator, and so let's just make that eighths. 4/8 minus 2 3/8. And again, we've created a fraction that is thankfully big enough for us to subtract this. So that makes a difference that is different from our previous two. So it's like we're refining the differences as well. Okay? And finally, click subscribe. Come back again. Hit that little red button, you know you want to, and come back again. I do try to help you guys with these videos. And if you're lucky enough to be in my class, we will be doing a whole new set of data in class. Write a sentence describing how you could create a more precise ruler. Remember, we were talking about precision and details to measure your pencil strip. So how could you do that? Well, I could, this is just a sentence answer, I could create a ruler with more increments. Okay, and that's really the secret. So we have used eighths, but if you take a look at your ruler, you might notice that there are, in fact, more pieces on there. So if I hold it up close to the camera so you can see, there aren't just eighths, there are 16 pieces. 1, 2, 3, 4, 5, 6, 7, 8. 8 is only halfway. 9, 10, 11, 12, 13, 14, 15, 16. So inches are broken into 16ths, and that's pretty typical. That's going to be the smallest amount of standard measure that you'll have in the USA. So I could create a ruler with more increments like 16ths. Or you can use the metric system because millimeters, mm, are very tiny. And so that is always a good option. If you look at the 16ths, see how big those are? And then flip that around and look at the metric system, and the millimeters are so tiny. Very cool way to measure and easy to convert because you just have multiplying by 10. Anyway, I hope this video was super helpful for you, and I will see you on the next one. Bye for now.